Happy Wednesday, guys. Today we are going to be covering using ratios and rates to solve problems. So basically I'm going to be showing you guys a few strategies and techniques in order to help us better analyze these questions. Our TEK for today is right up here at the top on 6.4b. And before I forget, we're going to need pages 193, 194, 195, and 196. So go ahead and pause the video and grab those for me real quick. Alright, so our essential question is, how can you use ratios and rates to make comparisons and predictions? So that's the question that we want to be able to answer by the end of this video. So we're going to start right here on page 193, using tables to compare ratios. And our question is, Anna's recipe for lemonade calls for 2 cups of lemonade concentrate and 3 cups of water. In Anna's recipe, the ratio of lemonade concentrate to water is 2 to 3. That's based off of lesson 7.1, which was ratios. So you guys should be familiar with that. And then it says use equivalent ratios to complete the table. And so equivalent ratios means it's the same as our regular ratio. We're just either using multiplication or division to find it. So if I've got 2 to 3, I'm multiplying by 2, and 2 times 2 is 4, therefore 3 times 2 would give me 6. And then if we continue going, so this is 2 times 2 right here, this one will do 2 times 3, and 2 times 3 is going to give me 6, and 3 times 3 gives me 9. And for our last one, we'll do 2 times 4. So 2 times 4 is 8. Oh, I'm sorry, that should be 5. My apologies, guys. Go ahead and scratch that one out. Got a little carried away there. And 2 times 5 should be 10, and 3 times 5 will give us 15. Alright, part B says Bailey recipe calls for 3 cups of lemonade concentrate and 5 cups of water. So in Bailey's recipe, the ratio of lemonade concentrate to water is 3 to 5. And so I've given you that little bit of help, and it's also right here. I want you guys to pause the video and fill out the rest of this table real quick. Alright, I went ahead and filled out the table, so if you want to go ahead and pause it and just double check your answers, that would be awesome. And if I want to compare these two tables, I need to first have a common denominator or a common number in my ratios. So the only one that is common for both of them is 15. So I'm going to go ahead and circle my 10 over 15 and my 9 over 15, and now I can compare the two. So if I look at D, whose recipe makes stronger lemonade and how do you know? Well, if I look at it, there's more lemonade concentrate up here in Anna's than there is down here in Bailey's. So Anna's lemonade is going to have a stronger lemon flavor because it has more lemon concentrate in it. So that would be our answer for D. Anna's recipe has the stronger lemonade because it has more lemonade concentrate. Alright, so that's just one example of how to compare ratios. So why don't you guys go ahead and pause the video and make sure you've gotten all that written down, and we'll answer part E as soon as you're done. Alright, so just to backtrack and use some of our prior knowledge, we're going to use inequalities to compare these ratios. So remember, our little alligators always want to eat the bigger number. Okay, so 10/15 is bigger than 9/15, and therefore 2/3 is bigger than 3/5. Alright, ladies and gentlemen, so I fast forward time a little bit, and now we're going to be on page 195, and we're going to look at reflect question number 3. This section, if you look at the top of page 195, is called using rates to make predictions. So basically we're going to see what would happen if we followed a trend, what would happen in the future. Could we or could we not have a specific outcome, alright? So go ahead and pause the video and get ready for this part. Okay, so question 3 says, in 15 minutes, Lena can finish 2 math homework problems. How many math problems can she finish in 75 minutes? Use a double number line to find the answer. So we've got some extra notes up here for double number line, but I think we can explain most of it based off of this question. But if for some reason you are having some trouble, you can look at this and try to solve some of this, or come see one of us in the morning and we can help out a little bit more. Alright, so it says that Lena can do 2 math problems in 15 minutes. So right here we've got our minutes and our problems, and over 15 minutes we can do 2 problems. Okay? So let's say that we wanted to find an equivalent ratio to compare with the rest of this. So what if we doubled it? Let's say that we wanted to know how many problems or how many minutes it would take her to solve 4 problems. Well, when we're dealing with equivalent ratios, we're going to do to one of our numbers, we have to also do to the second number. So if I multiply 2 times 2, I then have to multiply my 15 by 2. And so for 4 problems, it would take her 30 minutes. Okay? Okay, and if we kept this theme going, if I'm going by 15 minutes every time, I could have 15, 30, and if I added another 15, that would make this one 45. And so 15 times 3 is what's going to give me 45. And so therefore I would also have to multiply my 2 by 3, and 2 times 3 would give me 6. So that means that we could do 45, or we could spend 45 minutes and get 6 problems done. Okay, hopefully that's not as long as it's going to take you to do 6 problems, but you never know. Alright, so what I want you guys to do is go ahead and pause the video and try to fill in these last 2 blanks, and then we will see how many she can do in 75 minutes. Alright, so I went ahead and finished mine, and just to remind you guys, all of these are equivalent ratios. So if we had 75 to 10, that would be equivalent to 15 to 2. Just kind of trying to backtrack and make sure that you guys are remembering the stuff from this unit. So back to our original question, it says how many math problems can she finish in 75 minutes? Well, if we go look at our double number line, we've got 75 minutes and 10 math problems. So the answer to our question would be that Lena can do 10 math problems in 75 minutes. Alright, so once again, this is just another tool that you can use when you're trying to dissect some of these word problems you're going to be seeing tomorrow, and these are just some tools that will help you set up your information and your data along the way. Alright guys, I've got one more example I want to look at with you, so go ahead and turn over to page 196, and we're going to be looking at question number 2 right here. So go ahead and get that ready and then unpause the video. Alright, so question 2 says, Neha used 4 bananas and 5 oranges in her fruit salad. Daniel used 7 bananas and 9 oranges. Did Neha and Daniel use the same ratio of bananas to oranges? If not, who used the greater ratio of bananas to oranges? Oh, this is awesome. So this is going back to when we first learned about ratios, and we are going to have to find some equivalent ratios to compare these two. Alright, so Neha used 4 bananas and 5 oranges. So I'm going to come over here to the side and say that Neha used a 4 to 5 ratio, and her good buddy over here, Daniel, used 7 to 9. 7 to 9. And we want to know, did Neha and Daniel use the same ratio of bananas to oranges? Well, in order to do that, we've got to go back to the knowledge that we learned from our table, the first example I did during this video, and we have to have a common ground to stand on. So it's kind of like when we're messing with fractions, we have to have a common denominator to compare the two. So what we need to do is we need to figure out what an equivalent ratio would be for all of these numbers. Okay, so what I'm going to do is I'm going to go ahead and rewrite these ratios in a fraction form, because remember there are multiple ways to write ratios. And then we are going to find a common denominator to compare these. So I just know that 9 times 4 gives me 45, and that will be my new denominator to compare for this ratio. So if I do that, I'm going to multiply 9 times 5, which gives me 45, and therefore I have to multiply 7 by 5 as well, which gives me 35. And then up here, we're going to do 5 times 9, and then 4 times 9, which is going to give me 36. And so if I look at these two new ratios that I've made, I can now compare them. And back to the question, did Neha and Daniel use the same ratio of bananas to oranges? Well, these two ratios are not the exact same, so therefore they did not use the same ratio of bananas to oranges. And then it says, if not, who used the greater ratio of bananas to oranges? Well, Neha is our winner, because last time I checked, 36 is greater than 35. So the answer to this question would be that Neha used a greater ratio . Alright guys, that is the video. Make sure you answer the Google Doc questions tonight. The only person that has tutorials in the morning is Miss Sorrell, so everybody from every single class, go see her. Have a wonderful night. We'll see you tomorrow.